This is part 2 of simplifying fractions with radicals. So we already know our first one is to simplify the fraction, and then we simplify the radical, and then the last one now is rationalize the denominator. So going back, after using checklist part 1 and 2, we ended up with this. And now we have a part 3, this little radical here. And that's what we have to rationalize. Our denominator cannot contain radicals to be fully simplified. So let's try one, and then we'll get to that one problem at the end. So, fraction can't be done. Radical can be done. Which gives us 5a on top, the square root of b on bottom. We cannot simplify that. So again, go through the checklist. No for the fraction, no for the radical. Part 3 is the denominator. And how we rationalize the denominator is you multiply top and bottom because it's a fraction. You have to multiply by a radical to get in here. And all you're doing is giving that b a pair. So now if you have two b's, this will allow you to take a b out. So this is 5a rad b over the square root of b squared. And there's your pair. So this gives us 5a square root of b over b. And you go back through the checklist, simplify the fraction, done. Radical, done. There's no pairs. Rationalize the denominator. It is a rational, non-radical. And that's it. Let's try another. So, and you can go in any order. You could start rationalizing right from the beginning, but sometimes you don't need to. So let's reduce though to see if we do. That's 3, and that would be 135. So we have square root of 135 over the square root of 3. Right? And does 135 divide by 3? Let's find out. 135 divided by 3. It's 45. So yes, it does. That's square root of 45 over the square root of 1, which gives us a 1. So we don't have to rationalize the denominator. Just simplify the top. So we have a pair of 3's and 1 5 left inside. And there it is, 3 square root of 5. So rationalizing was not needed. Alright, let's go for the next one. So that would give us a 3 over square root of 7a. And there's nothing else we can do with those two. So now when we rationalize, if you have two factors inside of a radical, then you must multiply top and bottom by a radical with those two factors, because we need a pair of 7's and a pair of a's to take it out. So on top we get 3 square root of 7a. And now we're going to do the second one, the bottom part, a little quicker. So you have a pair of 7's, you take it out. You have a pair of a's, you take it out. That's all the radical is doing. When you multiply top and bottom by it, it's allowing you to remove it. And that is our final answer. So there's nothing left in the radical to remove. You can't cancel these because that's inside, that's outside, and there's no radical on the denominator. That's it. So try these two for me. Pause and give them a shot. And there's your answer. So all I did was cancel, and I get 1 and 8. 8a cubed b. Simplified the radical. Plugged it back in. Rationalized. And so square root of 2ab, I need another square root of 2ab, and that gives me a pair of 2's, so I take it out. A pair of a's, I take it outside the radical, and a pair of b's, I take it outside the radical. No more radical. And then I multiply it to whatever's left on the denominator. There it is. Let's try that one. And there it is. So I simplified the fraction, took out the pair for the a's, and so the radical now on the bottom, the radical 2 has to go. So I multiply it by a radical 2 and a radical 2. That gives me 6, radical 6 on top. And I now have a pair to take out, and then multiplying those together gives me 2a's. And that's it. And if you double check it, nothing will cancel because that's inside and outside. There aren't any pairs, that's just 2 and 3, and there are no radicals on the denominator. So it's always check, check, and check. you know you're done if it meets all three. Alright, so going back to this problem that we did last, we multiplied them together, split it up so we could simplify them, put it back together, and everything is done so far for part 1 and 2. There's nothing that will cancel. There are no pairs inside the radical, but we have a denominator with a rational. That's irrational. So, now that we know our trick, we just multiply top and bottom by radical 2, which gives us 21xy square root of 6x all over 5 and then a 2, which is 21xy square root of 6x over 10. And that's it. Nothing cancels. So again, no pairs. Can't cancel these. There's no radical left. It's finished. And that's it.